Hello everyone, I'm Hayden. I'm an alumni of the FTC Team 27361 Octopi Robotics and the CAD lead of Team 30831 Cuttlefish Robotics. Today, I will be covering the basics of how to CAD for FTC in Onshape, making a parallel plate drivetrain using Go Build It parts. Some things you will need to make this drivetrain, listed on the screen, and assuming you want to actually build it, are: please note that you do not have to build this drivetrain, nor am I encouraging you to. This is purely an example just to teach you the basics of CAD for FTC in Onshape. Let's dive in. First, we're going to start off by creating an Onshape document, assuming you have an Onshape account already created. I am not going to cover how to create an Onshape account as it's very simple to do, but once you have done that, you're going to go to the top left corner, making sure you're in the Owned by Me folder, Create, and Document. You can name this whatever you want. I'm going to name it Tutorial, just because obviously this is a tutorial that I'm making. So to start off, we're going to just explain briefly what a sketch is and what the other various features and things in Onshape are. So a sketch is essentially what you're going to make a lot of your parts in Onshape out of. These are the things that will allow you to make parts from the ground up, and you can have all the kinds of dimensions you want in a sketch, and you can make various different shapes out of it. Usually it's more of a flat shape that you make just out of a sketch and then extruding it. So once we make a sketch, you can extrude it, which I will just show an example of what a sketch looks like when you extrude it. Don't necessarily do this, I just want to provide an example. If you create a circle and then extrude it to a depth of 2.5 centimeters, bam, you have a 15 centimeter diameter circle and a 2.5 centimeter thickness. So I'm just going to delete this because it's completely useless. But one thing to note, if you have not already done this, go to these three bars in the top left corner, click Workspace Units, and make sure that your length default unit is in centimeter, or you can use millimeters. I personally prefer to use centimeters because this is what I've CADed with in Onshape for FTC ever since I started CADing, so I'm just most used to it. But if you prefer to use millimeters, you can go right ahead. It's a bit more precise. So with that said, let's get started with our parallel plate drivetrain. First, we're going to create a sketch on the top plane, and we're going to go in the top view right here, just so we can look straight down on it. What we're going to do now is we're going to hover over this rectangle icon, and we're going to click the down arrow on it, and click Center Point Rectangle. We're going to start on the origin point right in the center here, and we're just going to move it out. You can make your parallel plate drivetrain really whatever dimension you want as long as it works. Don't make it too small. You ideally want something a minimum of around 14 by 14 inches or around 36 by 36 centimeters. And the max that you can go for FTC is around 45 by 45 centimeters. I would not personally go that far. I usually go between 35 and 40. In this case, I'm going to go with 40. Or actually, no, you know what? I'm going to go with 36. Just because 36 is easiest for me to work with, generally speaking. You do not have to go with this, nor am I entirely encouraging you to. This is just purely an example. What we're going to do is these 36 centimeter lines represent the outer boundary of the robot. In terms of your chassis, you are not going to go outside of these lines. And this line here is going to represent the outer plate of your parallel plate drivetrain, and this one is also going to represent the outer plate on the other side. The way a parallel plate drivetrain works is you have two motors in the center, right here, and then you have a belt that leads to the mecanum wheels, and those mecanum wheels spin on a dead axle. I will explain later what a dead axle is. It's essentially just an axle that doesn't move, but yeah, it's a very simple concept. So what we're going to do to get started is we're going to start drawing a line in our sketch. A line you make by hitting L or just pressing the line button over here, and we're going to click on this point here. If I didn't mention it, in fact I didn't mention it already, you're going to want to construction these lines, which essentially just makes them a reference point in the sketch. They don't actually affect your sketch at all. It just, they essentially just are there and are kind of a visual reference. They will not be any, they won't play any crucial role in your sketch, necessarily. So what we're going to do, we're going to create a line going from this line to this line and making sure that it's horizontal. By default, in Onshape, your lines will snap to a certain constraint, so if you're making a line that's going to be near horizontal, it'll snap to being horizontal. And if you want to make a line that's vertical, it'll snap to being vertical. It's as simple as that. What we're going to do is we're going to hit D, which is the distance hotkey. And we're going to set the distance from this line to be 5.52 centimeters. And the objective here is so that we're going to extrude this parallel plate this way and this one this way, and the distance between these two will be 52 millimeters, and I'll explain why that's the case later. What we're going to do is we're going to do the same thing on the other side, so just make that line, extend it to both, and then hit D, line to line, set it to 5.52. Now we're ready to start making our parallel plate drivetrain. What we're going to do is we're going to go to the plane tool, which is over here, click on it, and what you want to do is it will be currently set on offset. Click on that and change it to plane point. What we're going to do is we're going to use the front plane or the right plane, whichever one you actually use to line your parallel plate drivetrain up. And we're going to click on this vertex of the sketch. Once that's done, we're going to click on this plane tool again, click on this plane, and put it on this vertex. Now that that's done, we're going to create another sketch. Our first sketch is going to go on this plane here. And what we're going to do, we're going to switch our rectangle to a corner rectangle. And what we're going to do is we're going to create the outer box that represents our parallel plate drivetrain. This will be the actual plate, and all of our plate geometry will be inside of it. So, what we're going to do, we're going to click corner rectangle, or just hit G, and you're going to want to hover your mouse over the vertices of the sketch. Do not actually click on these vertices, because then you will have your rectangle on them, and that is not what we want. What we're going to do is we're going to hover over the left one and the right one, and then whichever one you hover over second, you bring your mouse up and make sure that you have this yellow line that lines up with it, and then click and drag it over to the left, and make sure that it snaps vertically with the other one, and then just drag it as far as you wish, but don't go too far. I would say as long as this distance label doesn't really go beyond 9 centimeters, you're good. What you're going to do is you're going to hit D, and you're going to set the distance between this line and this line to be 1 centimeter. Now what we're going to do is we're going to create a circle by pressing C. We're going to expand this really as far as you want, and we're going to set the diameter of it to 10.4 centimeters. We're going to then click on the circumference of the circle and then the bottom line that we drew earlier and hit T. This makes it tangent to the bottom line, and as a result it will not move vertically. We're going to hit Q to construct it because we do not want this actually affecting our sketch, we just want this to be a reference point. Now what we're going to do is we're going to hit the point tool by either pressing Shift S or the actual tool itself. And we're going to hover over the center point of this circle, drag our cursor to the left, click, make sure that it's snapped, and then drag it up, click, drag it to the right, click. Now what we're going to do is we're going to go on this left point that we made to the far left line. We're going to set that to 0.4 centimeters. Then we're going to go to the top point, click on the top point and the top line, and we're going to set that to 1. Now what we're going to do is we're going to hover over the center point, make sure you have snapped your cursor horizontally, and then once you feel you're far over enough, drag it to 10.4. What this circle represents is the wheel. In this case, we're going to be using GoBuilda 104mm grip force Meccano wheels. What you can also do is use 96mm wheels, which would be 9.6 in this case. But our team uses the 104s just because they have much better grip and are overall much better wheels. So what we're going to do is we're going to do the same thing that we did with this circle here. We're going to hover over the center point, drag to the right, hover over the center point again, drag to the left. But in this case, we do not need to drag it up to the top. And the reason why is because in Onshape they have a feature called over-constrained sketches. I wouldn't necessarily call it a feature because it's more of an annoyance than anything, but if you go here and then set this, by default it'll go to 1, but this constraint is actually invalid. You can see that it's gray as opposed to white, and what it will essentially mean is that it doesn't need this constraint. And sometimes, if you actually put something wrong, then it makes the whole sketch basically an error. It says that it can't solve the sketch, and as a result, you can actually extrude the sketch and it'll basically be broken. So you don't need to make a point here. Don't do it. It'll basically just break the sketch or be completely useless. What you're going to do is you're going to hit D and then hover over this point, and then over to this line, 0.4. This is going to be the distance between the outer wheel and this is going to be the distance. This is going to be the distance from the wheel to the outer edge of the parallel plate. What we're going to do now is we're going to create our screw holes on our parallel plate. These are going to hold our standoffs that basically hold the parallel plates together. And the objective here is we're going to create screw holes that are 0.4 centimeters diameter or 4 millimeters. In this case, GoBuilder parts use 0.4 centimeters because they use M4 screws. However, if your team uses Rev parts, which by the way I highly suggest that you switch to GoBuilder. This video is not sponsored by GoBuilder in any way, but we just prefer GoBuilder on our team. Rev uses M3 screws, so your screw holes would be 0.3 in diameter, and you would also be using different wheels for this. Anyways, what we're going to be doing is we're going to hover over this point and drag our circle up. And then click. And then what we're going to do is we're going to hit D for distance, and we're going to go from this point here to the top line. I'm going to set that to 0.4. And then we're going to do the same thing. Hover over this point, drag the cursor down, 0.4, and then we're going to set the distance from here to here to be 0.4. Then we're going to create a screw hole that's over the center of this, 0.4. This will be where our dead axle is situated. And then what we're also going to do is we're going to hover over this point here, and then hover over this point here, drag your cursor down until it aligns with both of them, hit 0.4, and then do the same thing for the top, 0.4. There you go. Now we're going to do the same thing for the other wheel. This is already self-explanatory, so I'm just going to speed this process up. Okay, now that we've done that, we're going to add the screw holes for our motors. And this is going to be where things get rather complicated. You're going to have to memorize the dimensions a lot for these, but once you've made tons upon tons of drivetrains, which is essentially the way that I recommend you learn CAD, you can watch this tutorial as much as you want, but I would say you should only really start CADing a robot once you have been able to freely CAD a parallel plate drivetrain without a tutorial. What we're going to do is we're going to create a circle, just one for now, and we're going to set the diameter to 3.75 centimeters. And then what we're going to do is we're going to create another circle, 0.4, on the top left edge, the top left corner of that circle, then another one, top right, then another one, bottom right. Make sure that they're vertically and horizontally aligned with each other, by the way. So in this case, this one's vertical, this one's horizontal. And then we want vertical here, horizontal here. And now what we're going to do is we're going to set the distance from here to here to be 3.35, and then the distance from here to here to be 3.35. Then we're going to click on the corner points, so diagonals, and make sure that this is roughly in line with the center point, and then we're going to hit Shift M. What this does is this makes it directly in the middle, so you have it nice and right around the corners all equal. Now what we're going to do is we're going to do the same thing. We're going to make a second motor, horizontally aligned, and then just 0.4. Okay, now that we've done that, what we're going to do is we're actually going to go over to the GoBuilder website. You're going to want to go to Motion, Timing Belts and Pulleys, and then 5mm HTD Timing Belts and Pulleys. What we're going to do is we're going to figure out how we're going to have the pulleys on our drivetrain. Essentially, this is how you're going to figure out the exact center-to-center distance of the pulleys and motors on your robot. So essentially, the motor distance from the to the center of the wheel is going to be the center to center distance here that we're going to calculate on the GoBuilder website, and then same thing for this one. What this website allows you to do is you can get the right belt size by just inputting a center to center distance and making sure that you have the right pulleys. In this case, we're going to be using 24 tooth pulleys on our drivetrain because it is it allows for minimal belt slip, and they're also just the right size. What we're going to do in this case, I'm going to use an example. We're going to set the center to center distance to be 100 millimeters or 10 centimeters. This gets us a 64 tooth belt, which in turn GoBuilder does actually sell. In this case, if we were to set the center to center distance from here to here to be 10, and we were to set this one to be 10, this would be a perfectly functional robot. And basically a perfectly functional drivetrain. This works great, actually. However, we're not going to do that because in this case, we want the center of gravity on this drivetrain to be a little bit more forward so that we have space to mount things on the back in the scenario of us actually turning this into a full robot. We're not going to be doing that in this tutorial, but in this case, that's just what I want to do as an example. So, what we're going to do is we're going to go to GoBuilder, and we're just going to play around with the center to center distances. So we want this set of motors to be more to the front. What we're going to do is we're going to move these closer together, and let's just see what distances we get. Okay, so we're at around 8.5 centimeters. What we're going to do is we're going to experiment with what center to center distances GoBuilder offers. Now, because I'm a nerd, I already have this memorized. 82.4 millimeters gets you a 57 tooth belt, which actually GoBuilder does not sell. So you're going to want, I think, 87.4. There you go. That gets you a 59 tooth belt, so you can go here and go like this, 8.74. There you go. Now what we're going to do, we're going to set the center to center distance from here to here. And let's just see. I believe they have 120, which is 72 tooth. Yes, they do. Set that to 12. In this case, we're going to go with 8.74 and 12. And then what we're going to do, we're going to make these relatively close to each other. So we're just going to create another circle over this one, 0.8, and then 0.8. I'm going to make sure that these are construction, because otherwise these will severely affect our sketch. And we're going to make them actually fairly low on the robot. We're going to go with horizontal to this. Okay, now that that's done, we can actually remove these circles. And this is going to be our inner plate on our parallel plate drivetrain. We have finished this, and now we just have to move on to the next step, which is creating the outer plate. What we're going to do now is we're going to click on plane 2. Actually, hang on. I forgot to extrude this. We're going to extrude this in this direction, inwards on the robot. Going to make sure that you have these settings correct and set it to 0.32 centimeters. This is going to be the thickness of your plate. You can actually set it to really whatever you want, but in this case I'm setting it to 0.32. Now what we're going to do is we're going to create a sketch on plane 2. We're going to click on the front plane, and we're just going to use the Project Convert tool. Click on this whole thing, and just click on it. This gets you the outer geometry of the parallel plate, and allows you to, if you were to extrude this just now, it will be just this. But that's not what we're going to do. What we're going to do is we're going to click on all the screw holes except for the motor ones. So this one, this one, this one, this one, this one, and all of the others for obvious reasons. What you can also do in your parallel plate drivetrain for extra strength is, in this case, we would have a screw hole that's right here, but obviously the motor doesn't allow for that. So what we're going to do is we're going to put one up top, horizontally aligned with these. We're going to put a standoff here. Now what we're going to do, just going to project that one. What we're going to do now is we're going to project these motor holes. However, you're going to want to construction them because we do not actually want holes this big. We're going to go 1.4 centimeter diameter. And what this is actually the same diameter as a bearing. We're not going to put a bearing here because it's simply useless to do that, but it's just a nice thing to have in this case. What we're going to do now is we're going to extrude this. inwards. There. This is our outer plate done on the parallel plate drive. I'm going to hide this briefly because we need to make one more part. We're going to hit plane, and we're going to, instead of using plane point, we're going to do offset. The offset distance for this is going to be 3.2 centimeters. What we're going to do is we're going to make a sketch on this plane, and then we're going to project these screw holes here. This is going to be the part that holds our motors, and it's going to be fastened to the inner plate with standoffs. And what we're going to do is we're actually just going to project these circles here. And then what we're going to do, we're going to create 4 circles in the shape of a square for center distances. And then we're going to set the center to center distance vertically and horizontally for all of these to 1.6 centimeters. This is what you're going to screw your motor into, these 4 holes right here. Now what we're going to do diagonal points, and then to the center, Shift M for midpoint. Then I'm going to do the same thing on the other side, so I'll just fast forward this. Okay, now that that's done, what we're going to do is we're going to go over to the arc tool. Do not click 3-point arc. We're going to go click on this down arrow, and then we're going to click center point arc. Then we're going to click on the center point of the outer circle, and then we're going to drag it horizontally and then vertically. Set that to 0.4. Same thing on all the other outer ones. Don't do it with these because we don't need to. Okay, now that that's done, we're going to drag a line from all these points to each other. And then, bam. That is done. Now what we're going to do, we're going to extrude this. And let's say we're going to make it 0.6 centimeters thick. What we're going to do now is we're going to create another sketch on this plane here. And then what we're going to do, we're going to create a circle on each one of these screw holes. Set that to be 0.8 centimeter diameter. I will fast forward this just to make your lives easier. Okay, now that that's done, what we're going to do is we're going to use the fillet tool. This essentially just rounds sharp edges on parts. And what we're going to do is we're going to set the radius to 0.1 centimeters. And then fillet this, and just all of the sharp edges that you encounter, apart from this edge here. Okay, now that that's done, we have finished this part. Let me just make sure that this is all good. Yeah, we're good. Okay, now what we're going to do, we're going to bring this part back. And then this is where things are going to get interesting. We're going to first fillet all the sharp corners on our drivetrain. So we're going to go this one, this one, this one, this one, and of course same on the other side. And then what we're going to do now is we're going to click on this plane here. Just going to hide sketch 3 really quick because we don't need it. And now what we're going to do is we're going to use what's called a feature script. It's called Lighten. And what a feature script does is it's essentially it's almost like a plugin for Onshape. If this is installed by default, you'll just have to search it in the feature scripts, and then so I'll just show you. If you go to search Lighten and click this, add to toolbar, this will allow you to do pocketing on your drivetrain, and this essentially just makes it lighter, considering, assuming that you are CNCing this parallel plate drivetrain out of presumably aluminum or something of the sort, then this will allow the drivetrain to be a fair bit lighter. What we're going to do is we're going to create a sketch on this plane here, create a line from this point to this point, or really just any way that you want. You can pocket it in really any form. As long as there's decent struts each way, then your drivetrain will be nice and strong, but also quite light. So what we're going to do is we're going to, in my case, I'm just going to create lines from all of these. So we're going to go like this, and then we can just do that. And then we'll go from here to here, then from here to here, here to here, like this, then like this, then like that. And then what we're going to do is we're going to create a line that goes between all of the outer screw holes. Now what we're going to do, now that we've done this, we're going to use the lighten tool, and we're going to lighten this. So you can play around with what settings you want for lightening parts. What I prefer to do is I do 0.6 centimeter thickness of walls and 0.3 centimeter radius. You're going to want to enable trim faces with part, as this basically just enables thicker edges surrounding screw holes and whatnot. So we're just going to pocket all of these. And bam, now you have a pocketed outer plate on your drivetrain. Now what I'm going to do is I'm just going to change the color of these parts, because this is obviously rather ugly. You go to these parts, click on them both, and then right click, and then change material. We're going to set them both to, we'll go with this color. I like having this color on a lot of drivetrains. So now what we're going to do, we've actually finished the sketches for all of our parallel plates. What we're going to do is we're going to click part 1, part 2, and part 3, and then we're going to mirror this part, click mirror plane, and then click it front plane. This just mirrors the parallel plates, and now we have them on both sides. Now what we're going to do is we're going to insert them into Assembly 1. So you're going to want to click Insert, and then Current Document, Part Studios, Part Studio 1. And bam, you have all your parallel plates inserted. What we're going to do now is we're going to go into the parts to insert parts into our document. You're going to need to access the FTC parts library to do this. And what you're going to do is you're going to email the email that I have sent on screen, and just say you are part of whichever FTC team you're on, and say I'm requesting access to the FTC parts library. This will get you access to basically every single FTC part that exists, and some strange things that other people have made in here. What we're going to do in this case, we're going to go to Go Builda, Structure, Standoffs and Spacers, M4 Standoffs, and then we're going to find the 52mm standoff in this list, which will be this one here. What we're going to do is we're going to click the check mark there, and then we're going to use a mate. What a mate is it's essentially, think of it this way. It's like a connector between something. So if you mate this edge with this circle, then what it will do is fasten it to that. Simple as that. There are many different types of mates on Onshape. For now, all you're really going to need is a fastened mate. It's pretty self-explanatory. In this case, what you're going to do is you're going to fasten it to the inner plate, and then we're going to move this inner plate just out of the way for now. And then we're going to click on this circle of the outer plate, and then click on this one, and then bam, done. So something to note when you are fastening things to these Go Builda parts, such as standoffs. Your mate might be a little bit weird. So, for example, let's see. If I do it like this, and then I fasten it to this is what it's going to look like. And the reason for this is because the mate on the standoff is actually perpendicular to what it should be. So what you're going to want your mate to actually look like is you're going to want to hover over it first before you actually click it. But in this case, you can see how the mate is right in the center and it's perfectly in line with the actual standoff itself. If we move it over here, then it's not going to be like that. So make sure that your mate is right in the center before you actually use it. It's a little bit difficult to master, but typically as long as you're at this kind of angle and you get it on just the right spot, then it'll be just perfect for you. So I'm going to do the same thing to this on the other side. It doesn't matter which screw hole you put it in as long as it's one of these outer ones. And then we're going to move this out of the way. Oops. Fasten this. Bam. Now what we're going to do is we're going to use the replicate tool. The replicate tool is this one here. And what we're going to do is we're going to click on the standoff. And we're going to, instead of match edges on face, we're going to switch to match individual edges. Then we're just going to click on all of these screw holes. You can click on all the screw holes except for these ones that surround the motors. Do not go with those ones. And I'll explain why later. This is actually really simple to understand. Oh. I made an oopsie. Do not put your standoff on where the dead axle would go. So don't put a standoff here. You'll be using a rec shaft for that later. What you're going to do now is you're going to replicate this part here. Match individual edges, and then just do all the correct edges. I will speed this up, obviously. Okay, now that that's done, what we're going to do is we're going to insert a different part. We're going to stay in the standoffs for now, and we're just going to scroll down until we find the 32mm length M4 standoff. Insert that, do a fasten mate, and then we're going to fasten it to these screw holes that surround the motors. So, one here, copy and paste, obviously controller command C and controller command V. Then we're going to click on this outer ring, fasten it, bam. And then we're just going to fasten this part to that. Now that that's done, we're going to use the replicate tool, match individual edges, and then just fasten it to all of these guys. Do the same thing on the other side. Oh, yeah, also need I mention, don't do it to these inner holes here. I will explain why later once we get the motors in. Because that's what you're going to be fastening your motors to. Your motors are going to stick in through here, and then the screw holes on the motors will actually go straight into these holes here. Okay, now that we've done that, what we're going to do is we're going to insert a Go Build a Rec shaft. And it's not in structure, it's actually in motion. You go to motion, shafting and tubing, stainless steel rec shafting, 2106 series stainless steel rec shafting, 8mm diameter, and then find the 52mm length, which would be this one right here. Do not insert the version with the E-clip, go to the bottom one here, click on this mate, and then we're going to fasten that to this. Note that the side with the E-clip indent should be facing towards the outer plate. I'll explain why later. This is essentially going to be a point of reference. It's not entirely necessary, but it will help a little bit later. and then just do the same thing on the other side. Okay, perfect. So now we have our rack shafts on, and this drivetrain is basically assembled in terms of non-moving parts. What we're going to do now is we're going to create a new part studio, and we're going to rename this to Pulley. Now, this is where things are going to get actually rather interesting. We're going to use a derived function, and what that essentially does is it inserts a part studio from another document. In this case, we're going to insert a configurable pulley that will be 3D printed. So we're going to search and then hit derived, and then we're going to go to other documents, and then search Tristan's utilities. Then we're going to go to whichever document you want, really, any of these works, and then you're going to click on configurable pulley. Then you're going to change the various settings on this. So what we're going to do, keep the teeth the same, the length the same, the flange offset, all these. What you're going to change is the bore size. Change that to 14 millimeters, and then the hub recess size should be 1 millimeter. Then click generate, then click on configurable pulley. Done. Now what we're going to do is we're going to create a sketch on the top plane here. And what we're going to do is we're going to create 4 circles, 0.4 centimeters diameter, and then you're going to want to set these all to 3.2 centimeters apart. And then use the midpoint function, just like that. Now what we're going to do, we're going to create 4 center point arcs, one here, 0.4, one here, and it's pretty self-explanatory from here on. Okay, this next step is a little bit complicated. What we're going to do is we're going to click on this center point here, and then we're going to drag it out to the center point on this circle. Then we're going to drag it out to this center point, and then just go out of that, and then click on this and hit Q. Now what we're going to do is we're going to create another center point arc, this time right on the center of this at the midpoint, and then we're going to just drag it really anywhere you want, but don't make it touch anything, 0.4. Then we're going to create a line that's tangent to it. It will snap to being tangent, and what we're going to do in this case is we're going to click on these points, and then we're going to make it coincident. Bam. Now what we're going to do, we're going to do the same thing for this. Perfect. Now what we're going to do is we're going to click on these 3 sketch items, and then we're going to make a circular pattern. So if you see this tool here, the linear pattern, click on the down arrow and then click circular pattern. What we're going to do is we're going to set this to 4x, and then this center point of the circular pattern, drag it to the origin point. I know it looks like it was already on there, but Onshape doesn't actually know that, because Onshape can be a little bit weird sometimes with sketches, so you'll have to drag it back on to make sure that it actually snaps. And then, now we've done this, we're going to use the project convert function to project this bearing hole, and then we're going to extrude this to a depth of 1.1 centimeters, or 11 millimeters. Now what we're going to do, we're going to create a sketch here, go to the bottom plane, and then 0.8 diameter of all these circles on the center point of each arc. It will automatically snap to this, so you don't need to worry. And then we're going to extrude this. What we're going to do is we're going to extrude this in 2 ways. We're going to set it to remove, set the depth to 0.4, and then we're going to click second end position right here. This also extrudes it right through here. And what we're going to do with this is we're going to be able to put our screw straight through this right to here. And this will fasten it to the wheels. Now what we're going to do, we're going to fillet all of these sharp edges. Set it to 0.1 or really whatever you want as long as it works. Bam. Now, to make it easier for the printer to actually handle this, we're going to click on these edges here and set the radius to 0.2 for a fillet. Bam, done. So now we have created our pulley. I'm going to change the color of this, even though it's not entirely necessary. Just give me 1 second. Okay. Now what we're going to do, we're going to create 2 assemblies. 1, and then 2. Going to rename this to left wheel and right wheel. Now, we're going to go back to the parts library and go all the way back out, stay in motion, scroll all the way down until you get to wheels and tires. Then we're going to scroll down mecanum wheels, grip force mecanum wheels, and then left slant is going to go, or hang on, we're in the right wheel assembly, so we should actually go for right slant. And then left slant for the left wheel, obviously. Done. Now what we're going to do, we're going to insert from our current document, Part Studios, Pulley, and then just go here. And now you can see that this is actually not entirely going to work with the wheel. The side that you're going to want to fasten the mate to is the side that has the round, the screws, and not the nuts on the other side. What we're going to do is we're going to click Offset and change rotate about X to rotate about Z, and then rotation angle should be 45 degrees. And now just align it, rotate it along the secondary axis until it lines up. And then we're going to do the same for the right wheel. There was a step I forgot to do in the pulley. Rotate about Z, 45, and then rotate it. Bam. Just have to fix the pulley real quick. We have to do a sketch on the top, and then 1.5, extrude, remove, 0.1. What this is going to do is we're going to have our bearings flange go right into here, and this will be perfectly flush with the end of the pulley. It's really simple, and I'll show you what that looks like once we actually insert this bearing. What we're going to do is we're going to go out of the grip force mecanum wheel assembly, go stay in motion, scroll all the way down to the bottom, bearings, flange ball bearings, and then the top one, 1611 series flange ball bearing with 8mm Rex shaft. Now what we're going to do, we're going to create a fasten mate, and we're going to go with this edge here, this circumference. And then we're going to fasten it to this inner one right here, and bam. Now you can see the flange is perfectly flush with the pulley. We're going to click on this bearing in the instances. Don't just click on it here because then you won't copy the whole thing. Hit Command or Control C and then Command or Control V. We're going to do another fasten mate right here, like this, and bam, done. Going to do the same thing on the other wheel, so we're going to insert this twice, and then I'll just speed this up because it's the exact same thing. Okay, now what we're going to do is we're going to insert the screws. So this is really just cosmetic doing this. You don't actually need to do it, but in this case it just really makes the CAD look better and also gets you experience with inserting screws, so I'm just going to do that. You're going to want to go into Standard Content, Standard, ISO, Bolts and Screws, Socket Head Screws, and then you're going to want to go to Hex Socket Head Cap Screw. Set it to size M4, and the thread length should be 30mm. Bam. Done that. And then just click on this little mate connector here. Like that. There you go. Perfect. And then we're just going to replicate that. Do the same thing on the left wheel. Okay, now that we've done that, what we're going to do is fix this Rex shaft because that was done incorrectly. There. Okay, what we're going to do now is we are going to use a, I go to current document, assemblies, left wheel, right wheel. And here's where I'm going to teach you guys how to insert your mechanic wheels correctly. What you want to do is, in your drivetrain, you want your mechanic wheels to make an X shape with the treads. So in this case, this tread will be pointing this way, so assuming the pulley's on this side, which it will be, this mechanic wheel is going to be right here, because the tread faces this way. And then this mechanic wheel is going to be here, because the tread faces this way, and then it's going to make an X. So what we're going to do, we're going to use a slider mate. And what a slider mate essentially does is it doesn't allow rotational freedom, however, it allows it to slide along this. And that may not be seen as good entirely, however, I will show you guys why it is good in this scenario in just a minute. What we're going to do is we're going to actually fasten it to the inner race of this bearing. So don't click on any of these circles here. You're going to want to go with this one here. And then go over to the rack shaft. Click on this little circumference here. And then make sure that it is the correct way around, which I believe that this is. Yes, it is. Okay, now we're going to, oh, hang on, it rotated it. That should not have happened. No, we're good. Okay, so what we're going to do is we're just going to slide this right on over. This will actually be fastened to it a little bit later, and I'll show you guys how that's going to work. What we're going to do is we're going to do the same thing for the other wheel. Okay, done. Now what we're going to do is we're going to do the same thing on the other side, so copy and paste left wheel and right wheel, and then just rotate these guys around 180 degrees. And then we're going to do the slider mate process. Alright, so what we're going to do is we're going to insert our motors now. For a drivetrain, you're going to want 435 RPM motors because it's the perfect balance between speed and torque. You don't want 312s because they're going to be too slow and your robot's going to be a snail.
But what the hell, boy?
Go build a motion, motors, and then Yellow Jacket planetary gear motors at the top of the folder. Scroll all the way down to the bottom, and then find the 5203 series Yellow Jacket planetary gear motor with 435 RPM and 24mm length, 8mm rack shaft. We're going to insert that, and we're actually going to insert 3 more, because we need 4 for the drivetrain. Now what we're going to do is we're going to fix this part. So right click on one of these parallel plates, and then click fix. Then what we're going to do is we're going to do a fasten mate on this motor here, or really just any motor. Let's say it's the top left corner, or in this case, if we're looking from the back, it's the top right corner. So if we're going to fasten it to the motor mount plate, then we're going to want to do the top right corner, just like so. And then make sure that it's on the correct side and that you rotate the secondary axis as needed. And bam, that's on. So we're going to do the same thing for this guy here. Bam, done. Okay, now we're going to unfix this part because Onshape doesn't like it when there are more than 2 fixed parts at a time, or more than 1. Going to fix this parallel plate. In this case, that'll be the top left corner. So go there. There we go. And go there. Bam, done. Okay. So now what we're going to do is we're going to insert our pulleys. And what we're going to do is we're going to go back to motion, and then timing belts and pulleys. 5mm HDD timing belts, 5mm timing pulleys, and then we're going to find the 8mm export 24 tooth. This is the correct one. So we go with this one, and then we're going to do a fasten mate. Going to go like this. And then we're just going to make sure the rec shaft aligns, and then we're going to have to offset this to just the right amount. So what we're going to do is we're going to offset along the z-axis, and let's just say we want to offset it to 1.5, 1.6 maybe. There we go, 1.6 works. And we're going to then replicate this guy on this one. Bam. And then duplicate this. Go like that. And then go here. Negative 1.5. Correction, I screwed that up. Okay, and then we're going to replicate this. Alright, done. Now what we're going to do is we're going to insert the belts for this. Okay, to add the belts, what we're going to do is we're going to start a new part studio. And once that's done, we're going to create a sketch. Well, actually, hang on. There was something I forgot. So to be able to do this belt generation, you need to install a feature script in Onshape. I will provide the link to the document at which you need to install this in the description, and I will walk through the installation process very briefly. Okay, so once you're in the document, what you're going to do is you're going to go over to the tab at the very far right called Belt Gen FS, and you're going to go to the Belt Gen Example tab, and you're going to, at the top, click Custom Features, and you'll see Belt Gen right here, and click on the down arrow, and then just click on Belt Gen. And then this will automatically get added to your toolbar when you are using other Onshape documents. So if we go back to our tutorial document, what we're going to do, you can see that this is in my feature scripts. I actually have it twice for the purpose of this. We're going to go back to the main assembly, and we're just going to measure the pitch of this 5mm HTD timing belt. So what we're going to do, go to the Go Build a website, Motion, Timing Belts and Pulleys, scroll down to 5mm HTD, go to Pulleys, and then we're going to do any one of the 24 tooth pulleys, and then we look at the pitch, which in this case is 38.2 millimeters. So what we're going to do now is we're going to create a new part studio for the belts, and we're just going to call it belt. And then what we're going to do is we're going to measure the center to center distance. So we're going to go back to our original part studio and then go to our first plate sketch. We've got 8.74 and 12. So what we're going to do is we're going to put in our pitch, which was 38.2 millimeters. And then we're going to set the center to center distance, just like that. And then just put it right on the midpoint like this. Now what we're going to do is we're going to go to our toolbar tab. We're going to use the belt gen, click on the circumference of the first circle twice, and then click on the second circumference once, and then click generate teeth and set the width to whatever width you have your pulley set to. In the case of, if you're using Go Build a Pulleys, you want it to be 9 millimeters. Bam, we now have our first belt generated. We're going to have to generate the other one now, which will be 8.74 centimeter center to center distance. So we are going to input that really on any face that you want. 3.82, 3.82 again. And center to center distance was 8.24. now we just use the belt gen, this one, and this one, doesn't matter whichever order you're in. Generate teeth, 9mm. Perfect. Now what we're going to do is we're going to go back to our main assembly, and what we're going to do is we're going to insert both belts. And next thing we're going to do is we're going to create a mate connector. We're going to press this button or hit Control M. And this area of the belt, you'll see if you move your camera around how it's right in the center of this bit, right on the center of this arc essentially, but it's also right in the middle of the belt. This is exactly what we want. What we're going to do is we're going to utilize that, make sure that it is right in the center, do the same thing on the other side, and do it for both belts. Okay, now what we're going to do is we're going to create a revolute mate. And we're going to go to the 3D printed pulley that we're going to have, and we're just going to hover over this little piece here that's right in the center of each little tooth indent. And what we're going to do is this actually puts the mate connector that we're using right in the center of the pulley. So we're just going to click that, and as you can see, the belt is quite literally, not anymore, when we actually fix it, you can see that it is quite literally perfectly aligned. What we're going to do now that we've done this is we are going to create another revolute mate over to the pulley here that comes off the motor shaft. Click on this little end edge here, that's the farthest one. Make sure that your mate connector is right in the center, and then you're going to set your offset to 0.6 centimeters. There you go. So that has perfectly aligned our belt with both pulleys, and also this pulley here, even though it was on the slider mate, is now prevented from moving. So what we're going to do is we're going to do the same thing for the other belt. And I'm not going to fast forward this part just so you guys can understand the process a little bit. Go this little piece here. Then mate connector, outer piece, offset, 0.6, or in this case negative 0.6. Never mind, we need to flip this, I guess. Okay, perfect. Now we've got both our belts in on our drivetrain, and the wheels are perfectly aligned, and it looks great. So what we're going to do is we're going to duplicate these belts and do the exact same thing on the other side of the drivetrain. So just something to note, you're going to want to fix both of these. Onshape won't exactly like that, but there's nothing it's going to do about that. It's just going to complain, but there's nothing that will actually be an error. Okay, now that we've fastened both belts to the plates, the pulleys, what we're going to do, you can also hide all mate connectors by pressing K. What we're going to do is we're going to go back to the original Parts Studio, and actually coincidentally I'm in the sketch that we need to use. What we're going to do is at the back of the robot, or the front, my apologies, whatever side you have predetermined is the front. So in this case, for me, it's this side. If you want the front to be here, that's completely fine. What we're going to do is we're going to create 4mm size, 4mm diameter screw holes that are 3.2 centimeters apart. Okay, so once you've done that and made them 3.2 centimeters apart, you can make them use the midpoint constraint to make these right in line with the center here. And then what we're going to do is we're going to do the same thing on the other side, except that we're not going to have a second set right here, only one. And this will be the back side of the robot. And because this is finicky, what you're going to do instead of using the midpoint constraint is you're going to create two lines from this circle to one line from this circle to this circle, one line from this circle to this circle, and you're going to construction them and then hit E to make them equal. Then what we're going to do is we're going to create a distance constraint right here and set it to 1.6 centimeters. This is going to be our mounting holes for our U-channels that will actually fasten the chassis together. So what we're going to do now is we're going to unfix one of these parts because it doesn't matter the orientation that it's in, even if Onshape severely screws it up, which it does sometimes. What we're going to do now is we're going to go Insert, Other Documents, and then go to the FTC Parts Library, go Build a Structure, and then you're going to want the mounts, and then you're going to want quad block pattern mounts, the one at the very bottom. Then go like this, insert it, and then what we're going to do is we're going to go to the hole on the bottom, so the side that's flush with the rest of it, so not the one where these four things are sticking out. And what we're going to do is we're going to orient it in whichever way is needed, and then we're going to duplicate this dual block mount and put it on the other parallel plate. Just like so. Then what we're going to do is we're going to grab a Go Build a U channel, but first actually what we're going to do is let's just determine the distance on the inside, the inner distance between these two plates. In this case it is 24.32 centimeters, so what we're going to do is we're going to get a 8-hole U channel, I believe, which will be exactly 240 millimeters long. So go to Structure, Channel, 1120 Series U channel, and then scroll all the way down to the bottom, or not the bottom, sorry, and go 9-hole, 240 millimeter length. Then what we're going to do is we're going to have to orient this thing correctly, so what we're going to do is just rotate it 180 degrees so that the flat side is facing straight up like this, and then you have the exposed side facing straight down. And then we're going to, we actually don't have to rotate this 90 degrees. What we're going to do is we're going to select the very corner screw holes here and just fasten it to this guy like this. Make sure that you have the right side, just like that. Bam! Now we have this U-channel fastened to the chassis. Okay, rotate this 180 degrees, like so. And then once we've done that, we're going to take the top corner, just like that. And then fasten it to that side of the U-channel, and then bam! We have our parallel plates now sandwiched together. So what we're going to do is we're going to fasten the other side. So go build a structure, mounts again, but instead of quad block pattern mounts, we're going to go with a dual block mount. Oopsie. And we're going to use the 1205 series dual block mount, this one, the second option here. And then we're going to grab a U channel. Nine hole 240. And just insert that. So the key here is you want this side here, the side that sticks out, to touch the bottom of the U-channel, but you also want to make sure that this screw hole, you want this face to be sticking out of the U-channel and making sure that it's fully out. So in other words, the perfect orientation for this would be 180 degrees around, and then rotate it 90 degrees, and then bam. Now what we're going to do is going to create a fasten mate and just fasten it like so. Then what we're going to do is we're going to duplicate this quad block mount, rotate 180 degrees, create a fasten mate, and do the exact same thing on the other side. Now that that's done, what we're going to do is we're going to fasten this to the parallel plates by going like this, making sure that it is the right way around and in the right orientation, and then bam, it's fastened. So the next couple steps after this are optional. They involve adding screws to your drivetrain and also odometry pods. That one is completely optional, but for being a good FTC team, it is obviously crucial to have odometry. So if you don't want to watch the step, then you are absolutely free to go ahead and watch another video, as if you weren't free to do that the entire time. Yeah, that's basically it for now, but if you want to learn how to insert screws and odometry pods, it's pretty simple. I will show how to do that right now. Essentially, actually we did already go over inserting screws. Go to standard content, and in this case we're going to go with a button head screw, socket button head screw. Thread length 8mm is fine for this. Insert, and then we click on that mate connector there, fasten it here, like so, and then we replicate the crap out of it. Make sure that you have it on match individual edges. Make sure you fasten it to these four corners screw holes on the U-channels. And then also replicate it on the other side. Make sure that you get these inner screw holes too. Perfect. Now that that's done, we can go ahead and insert our odometry pods. So we're going to go over to Other Documents, go Build, and we're going to scroll down to Electronics, click on Electronics, then click on Odometry. Then you're going to want 4-bar odometry pod, or another form of odometry, but this is what my team chooses to use. And wherever you put this really just depends on what you want. So in this case, you're going to select that mate connector, assuming that this is the odometry pod that you want to face to the side. So like this. What we're going to do in that case is, for aesthetic purposes, I'm going to mount my odometry pod right here. Just like that. And then we duplicate it, making sure that you click on the assembly and not just one of the parts of it itself. And in this case, you're going to want the top right. And we're going to fasten it just like that. Bam! You have your odometry pods, and as a result, you now have a fully completed parallel plate drivetrain. Thank you guys for watching, and I really hope that you found this video helpful. I do plan on releasing more CAD tutorials in the future. My personal advice with CAD, especially if you're new to it, is that It takes time to learn, and it's not easy, but once you get the hang of it and practice, it is actually kind of enjoyable, and it is relatively easy. I myself am speaking with around maybe 3 or 4 months of CAD experience at this moment, so it is a bit of a steep learning curve, but if you're able to learn things quickly and you have a decent amount of time, reasonable amount of time that you can put into CAD, then you should be able to learn it very quickly. So yeah, thank you guys for watching, and I'll see you next time. Bye.